All right, so today, let me just get my computer set up. We are focusing on earthquakes. Here we go. And you have your guided notes right here. They look just like this. So I'm going to do this guided recording. So I go through these once and I save my voice. So here we go. Follow along and fill in the blanks. All right, earthquakes. So, as with volcanoes, earthquakes are not randomly distributed all over the globe. Right? We did a graphing activity, we mapped those, and we know about where they occur. We focused on the Ring of Fire, but earthquakes and volcanoes really occur at the boundaries between plates. And then this is where friction causes them to stick together. Okay, so we have two basically rocks, and friction causes them to stick together. But they continue to move, so the energy continues to build up, and then as the energy is released, that's the fault breaking. So faults can only withstand so much pressure, and then they break. When they break, they release a ton of energy. So where do they happen? Most often they happen where plates meet, at fault lines, or we call them tectonic boundaries, plate boundaries, things like that. Sometimes in the middle of a plate where the crust can become very heavy and drops like a sinkhole. Okay, so some of my classes I talked about how Michigan is a sinkhole. It's sunk because of the glaciers that have retreated hundreds of thousands of years ago, but it's slowly coming back up. Like if you were to jump and record a trampoline, so jumping on a trampoline. So right now Michigan is pushed down, like when you're jumping on the trampoline, and then when you're coming back up, that trampoline comes back up. And that is somewhat what's happening. This example is also the Mississippi River Delta. A lot of earthquakes along in there. All right, friction causes the plates to get stuck, building up pressure. And when the pressure is released, an earthquake occurs. Okay. The point where the earthquake starts is called the focus. Okay, so looking at this diagram, the focus right there, that is the center. That is right where the earthquake starts. And I'm sorry if you can hear my dog, he's running around underneath my feet. So, we'll come back to this diagram a few more times. This one's just about the focus, which is where that earthquake starts, that center part where that fault slips. That energy is released. Okay, the epicenter. The epicenter is usually more of an interest to us because it can be visited and easily seen. So we can actually go to the epicenter because the epicenter of the earthquake is on Earth's surface. Okay, so this is where we do our research about earthquakes. Okay, so earthquakes, where do they form? Look at this diagram first. And this is a subduction zone. We have oceanic crust here coming into continental crust. It is a convergent boundary still. This is the subduction zone of the convergent boundary. See right here, convergent trench. Okay, so we've got this oceanic crust and it is going down into the ground. We have the hot magma that is being heated because water mixed with rock and extreme heat and pressure is going to create magma. Okay, so this magma is going to start rising to the surface. At this subduction zone, this is where we have earthquakes too. Volcanoes and earthquakes. You really don't want to live in these areas. Okay, so the deeper earthquakes occur at subduction boundaries of convergent plates. Okay, and then the shallower earthquakes occur at diverging boundaries. Okay, so we've got these deep earthquakes that occur at subduction boundaries. Okay, so they're down deep inside the earth, and the reason they're down there is because we have that layer of the earth that is subducted. And if you were to see me right now, you can see my hands are doing that thing where you show subduction. Okay, so you could do that if you'd like. Shallowest earthquakes, those are at the diverging boundaries, which are the boundaries that are just pulling apart. Okay, they're just pulling apart. Shallow earthquakes occur right there. All right. The epicenter of an earthquake is the point on the Earth's surface directly above the focus. So we talked about how we like to focus there. We focus our effort there because it is on the surface. Okay, this thing about seismic waves we're going to come back to. But seismic waves move from the focus, which is where that center earthquake starts, and it moves out in all directions. Okay, let's talk about the types of seismic waves. What are seismic waves? Okay, when plates move at the focus, all of the energy that was building up due to friction is suddenly released in seismic waves. Okay, there are three types of seismic waves. The first type of seismic wave we're going to talk about is called a P wave or a primary wave. These waves are the fastest seismic waves. They travel in a push/pull motion and can move through solids and liquids. Okay, so you have to diagram these in your notes, so make sure you're drawing them. You can draw them in any way you'd like, whether they be lines or circles or whatever's easiest for you. But P waves are like a push and pull. So imagine having a slinky, and we did this. We did this when we talked about waves. They are like longitudinal waves. So it's like you pushing the slinky, okay? And you've got some, looking at the diagram, you have some areas that are compressions, refractions. You have some that are squished together. Those are the compressions. Spread it more apart are the refractions. Looking at here, we have another different diagram. We have extensions, which are the waves that are a little more stretched out, and then compressions when the waves are pushed together. And that is what a P wave looks like. Okay, seismic waves. Hold on one second. I'm going to go let my dog outside. He's got to go to the bathroom. Okay, so S waves. We're on to S waves, or what we call secondary waves. They're always the second waves detected. So the P waves come first, and then S waves come. And they are slower than the P waves, hence why they come second. They travel in a side-to-side motion and can only travel through solids. Okay, so this is about the best picture I could have. It's not really up and down, it's sideways, kind of like a snake. I guess I should have put a picture of a snake in here because they slither kind of like a snake. That's disgusting. I hate snakes. Okay, last type of wave. We call them surface waves. They are the slowest, but they are the most dangerous to us. Okay, these disfigure and break rocks as they pass through it. Okay, sorry about that interruption there. We finished off, I just had to cut the movie. So we finished off with different types of surface waves, or except different types of seismic waves. Specifically, we ended with surface waves. And now let's talk about this thing called the shadow zone. So all three of the waves, P waves, S waves, and surface waves, they originate at the focus of the earthquake. And then they move outward in all directions. So as they move down through the Earth's interior, several things happen to seismic waves that affect our ability to detect them. So as a P wave travels through the interior, they encounter layers with different densities. Each time this happens, the wave refracts or bends. This refracting causes the path of the P wave to be shifted. It's just like light hitting water. When this P wave travels through the different densities of the Earth, which we know that as you go through the center of the Earth, density increases, then the wave is tilted slightly at an angle, it's refracted. Okay, so S waves. As S waves travel through the interior, they are stopped by the liquid outer core. So S waves cannot travel through liquid. and then we know that the only layer of the Earth that's liquid is the outer core. So the combined effect of P-wave refraction and S-wave absorption is that some areas on Earth will not receive any type of seismic wave. The area that is not hit by any seismic wave activity is called the shadow zone. So, looking at this diagram right here, spend some time and look at it. So, we have, you can tell how the different waves refract going through the different layers. And because S waves do not go through the core, we have these areas where there's no P waves, or excuse me, S waves. The rest you are free to go through. We are not really tested on it, but it's still some cool stuff about earthquakes, how different faults break, and how earthquakes move. So we're not going to go through this right now, but finish up your notes and make sure you've got everything here filled in. You have everything diagrammed that is asked to be diagrammed, and you're good.